Exponential derivatives, product rule, Leibniz's notation. So, we have a function y, and inside that function we have a to the power of x. A can just mean a number. It's just like a 7 or a 10 or whatever. It's just, you can put any number in there and it works, any real number, and it's to the power of x. Now, if we want to derive that, the answer we would get is ln of the number multiplied by the number to the power of x. So, when we derive it, remember that the ax stays there, but then you multiply it by ln of the a. Not ax, you multiply it by the ln of the a. I'll do an example of that in a minute, but that's the gist of it. And this is the product rule, where we have y equals u multiplied by v, and the derivative of y with respect to x is v multiplied by derivative of u with respect to x, plus u multiplied by derivative of v with respect to x. And now for some examples, get to it. Let's say we have y equals 7x times x squared. We have a u and a v, we'll label them. We'll make u equal to 7x, and we'll make v equal to x squared. Now, if we write out the formula for the derivative, it says we're going to need the derivative of the u and the derivative of the v. The derivative of the u, we said that when we have a number to the power of x, when you derive that, we get the ln of that number multiplied by that number to the power of x. Just like before, and with v being x squared, the derivative is 2x. If we input these values, what we end up with is v is x squared, derivative of u, ln 7 multiplied by 7 to the power of x, plus u, which is 7x, multiplied by derivative of v, which is 2x. And that's really it. You can rearrange it and make it look a little fancier if you want, but that's fine. I'll leave it like that. And now we'll do another example. So, say example 2. We'll have y, it'll equal ln x multiplied by 10x. We have a first function multiplied by a second function. We'll make u equal to ln x, and we'll make v equal to 10 to the power of x. Just like before, if we write out the formula for the derivative of the product rule, is v times the derivative of u plus u multiplied by the derivative of v. We got to find the derivative of u and the derivative of v. The derivative of ln x is just 1 over x. I have a video on that if you want to check it out. I'm not going to explain it now. But the derivative of 10 to the power of x is just like before. You have the ln of that number, in this case it's 10, and you multiply it by that number to the power of x. If we fill this in, the answer we get, v, 10x, multiplied by derivative of u, 1 on x, plus u ln of x multiplied by the derivative of v ln 10 times 10 to the power of x. That looks fine to me. I'm just going to leave it there, but you can change it if you want, make it look nicer. But I'm going to do another example. Let's say we have 7 to the power of x multiplied by 10 to the power of 10x. Now we'll use a little bit of the chain rule in here. I'm not going to do the notation of it, only because it will take up too much room. But there are videos on how to do the chain rule, and if you do struggle on that topic, I recommend watching them, or watching other videos, just learning the chain rule in general. But so we have our first function, and we have our second function. The formula is v multiplied by derivative of u plus u multiplied by the derivative of v If we separate it, we put u as 7x, 7 to the power of x, and we put v as 10 to the power of 10x. Derivative of u, just like before, we have ln of the number multiplied by the number to the power of x. Now here, very similar, almost the exact same. I'll actually do it down here. Almost the exact same, but we have invisible brackets that are now visible, but basically means we'll do the derivative of the outside and then we'll multiply by the derivative of the inside. So the derivative of the outside, just the same as before, ln of that number multiplied by that number, 10x, and then we got to multiply it again by 10, because with the chain rule, you multiply it by, you do the derivative of the outside, and then you leave the inside the same, and then you multiply it by the derivative of the inside. So in this case, we do the derivative of the outside, 10 to the power of an unknown, that's what's up here, and then that's ln 10 multiplied by 10 to the power of the unknown, and then once we're done with that, we focus on the inside. Now the derivative of 10x is just 10, so we multiply it by just 10. I wrote it down here because I can't fit it, but I'll get a new page and I'll put all the values on it. So the formula, or the equation, will look like v is 10 to the power of 10x, derivative of u with respect to x multiplied by the derivative of u with respect to x, being ln 7 multiplied by 7x, plus u, which is 7x, multiplied by the derivative of v, multiplied by, we'll bring the 10 out the front, 10 ln 10 to the power of 10x. That's poorly drawn. But because, you can't really see that, but 10 to the power of 10x, can't see that really either, but because we have both a 10 to the power of 10x and a 7 to the power of x in here and in here, we can factor those values out. So we'll factor them out. 10 to the power of 10x multiplied by 7 to the power of x, bracket, ln 7 plus 10 ln 10. Now all that I've done here is just brought the 10 to the power of 10x out of both sides and the 7 to the power of x out of both sides. So essentially, if we expand these brackets and we multiply both the 10 to the power of the 10x and the 7 to the power of x to both that ln 7 and 10 ln 10, we will get this up here. This is just a neater way of writing it. And that's my video on exponential derivatives. I hope this helped. Thanks for watching.